Good day to all. Today we are going to see about the classification of load torque. See what is the load torque? We will see in that classification of load torque. Various load torque can be classified into broad categories, which is first one is active load torques and the second one is passive load torques. The load torque which has the potential to drive the motor under the equilibrium condition are called active load torque. The main concept of this load torque is here. It is used to drive a potential to drive one under equilibrium conditions. If the motor with running of that equilibrium condition, then it will be called as a active load torque. For example of this active load torque is torque due to force of gravity. See, the force of gravity will have a active load torque because that's in that equilibrium condition. Then again the torque due to tension. Then load torque which always opposes the motion and changes their sign, reversible of their motion are called passive torque. Whereas in that active torque we have a equilibrium condition. We have a equilibrium condition in that active torque. Whereas in passive torque we have a opposition of the motion, which means we have a sign. Their sign, the positive may be negative, the negative may be positive. The changes of sign and the reversible of the motions are called the passive torques. For the example of this passive torques, here the torque due to friction and the cutting, etc. This is the passive torque. The active torques is a torque due to gravity. That is the active torque. The components of load torques. What are the components of load torque? See, the load torque TL can be further divided into the following components. First one is friction torque. Friction will be present at the motor shaft and also in various parts of the load. The torque TF is the equivalent value of various friction torques referred to the motor shaft. Then the vintage torque. See, vintage torque and this friction torques is also have a components of load torque. In that vintage torque, when the motor runs, the wind generates a torque to the opposing positions. As we saw earlier, if it is in the passive torque, the sign might be changed. Whether if it is positive or negative, the sign might be changed. So, this is a passive torque as we know already. Here, when the motor runs, wind generates a torque opposing the motion. This is known as the vintage torque. The torque required to do useful mechanical work. The nature of this torque depends upon the particular applications. What are the applications? We'll see. See, it may have some functions of speed. It may be time invariant or time variant. Whether it may be time variant or invariant with the speed, its nature may also changes with the loads of mode of operations. The friction torque can also be resolved into three components. What are that component? See, the component TB varies linearly with the speed is called viscous friction and is given by the VMT equal to B omega, where B is the viscous of the friction coefficient. Another component TC. First one is TV and this one is TC, which is independent of speed, is also known as Coulomb friction. This is the viscous friction is dV and the Coulomb friction is Tc. Likewise, the third component Ts accounts for that additional torque present at a standstill. Since Ts is present only at a standstill, it is not taken into an account in dynamic analysis, which is that vintage torque is Tw, which proportional to the speed squared. See, these are all come under that passive torque. As we see here, that passive torque is the sign will take the space. This sign will be negative or positive. Most of the time it's negative. It is called that passive torque. This passive torque also having the components like friction torque as well as the vintage torque. In that vintage torque, the motors generate the torque opposition the motion. Because see, if the motor is running in that clockwise, then it will opposite that particular running. If it is in that anti-clockwise, then it will go into that clockwise. So that's the thing we are saying here. It is a wind generated torque opposing the motion. Then the torque required to useful mechanical work. Likewise, we will see the vintage torque, and this torque also be resolved with that three components we have seen already. That is, one is viscous torque. This viscous torque mainly depends upon that torque which is in that component T where is linear. That Vmt equal to B omega. Omega here it's a speed of that particular thing, where B is the viscous friction of coefficient. Then the other component Tc, which is independent of speed. See here, the speed here is in that viscous friction. The speed varies linearly, because which means some changes in that speed. That is mainly denoted here. So some changes varies linearly or varies differently, that doesn't matter, but that changes in the speed, that is that viscous friction. Whereas in that Coulomb friction, which is independent of speed, that is called that Coulomb friction. Same like as in that third component, Ts accounts for the additional torque present at a standstill. Standstill means whether it might be independent or it is linearly varying, that is the standstill. Since Ts is present only at a standstill, so it is not taken into an account of dynamic analysis. What is that dynamic analysis? Dynamic analysis to conclude with that speed. So this component is not taken in the account of dynamic analysis. Then the final one is that vintage torque Tw, which is proportional to the square. See, mainly this, as we have seen earlier, this speed we can control. How we can control this speed? We can apply to the negative sign of that motor. That is also one of the important thing, that we have to change the sign. Otherwise, we have to change the phase frequency, as we have seen in that quadrant operations. Likewise, that speed with the help of the torque, the speed and torque relations is much important in that particular operations. So here the components of that torque is that vintage torque Tw, which is proportional to the speed squared, which means the Tw is proportional to the speed squared. That is the main concept of that vintage torque over here. These are all about the active and passive load torque. Thank you.